Right, thanks for coming back on time. We've got our next talk, which is from Mauro and Alessandra about automatic workarounds. They're from the University of Lugano, and thank you very much.
Thank you. So I'm Mauro, and I'm from the University of Lugano, and I present a a work in progress in Lugano about automatic workarounds. And as most of the academic work will be more like a look ahead rather than what we can do today. And I'd like to give you really a different perspective in what we are doing. This is a picture that I see as a metaphor of what is going on today. Whatever you have is when you have a problem in your system, whether it's actually during development, whether it's during maintenance, whether it's during operation, you have to go in a testing environment. So if your aircraft does not leave because the pilot sees this red light, he would actually call for maintenance. And I've been actually personally stuck in the airport for a few hours, just waiting for the aircraft to be repaired before leaving. And the question is really this, when you actually go through testing and through maintenance, whatever is automatic, is manual, is tool-driven, tool-assisted, not tool-assisted, by expert, by non-expert, you have to stop operating, and you cannot operate while testing. That's actually the main problem that we see. And what we're trying to do in this new project is really to move to a completely different perspective, which is actually represented metaphorically with this guy, which means basically you don't really have to do anything. What you want to do is you can probably, I don't think you can, get everything out, get the human out of the loop or get rid of testing. But what you can do, and what we hope we can do, is basically have someone or the system itself trying to repair itself. So instead of actually have to stop and wait, you would prefer to have the system working for you and maybe continuing working. And that's actually a very big saving in terms of time. Now, let me give you the perspective from the more web-oriented perspective. If you if you're a user of a web application like up there, and a failure occurs, what happens is that you can't do much. You basically have to report to some bug report systems. Actually, you have to report as a user to your application developers. The application developers may or may not be reachable. Eventually, he will actually report to the bug report systems. And someone, probably in this room, will look at the bugs and with their own priority, maybe low priority for them, will try to fix the bug, will be annoyed by this new error bug report, will ship the bug out, and it may take hours, days, weeks. I mean, as a user, I've been waiting for weeks, sometimes even more, just for the bug to be fixed, probably because it was not in the priority list of the Google developer. And that's actually something that you can simply stay, and you can't do much about that. And what we really want to do is we want to move to a completely different scenario, which is represented in this way. This is the scenario that I'm trying to explain how to reach, which is whenever the failure occurs, you don't really look for your Google developer to actually try to fix the fault, not always at least. But you'll notify the failure to the application, and that's one of the first hypotheses we do, which actually works very well in web application, which is you need to have someone who tells you the application failed, which may not be easy in all the cases, but then it's easy because you actually look at the application and you see the application does not react as you expect. So you get something you don't want, and you notify that failure to the system, and instead of going through this partially manual, partially automated, partially asynchronous loop, which in days, weeks, months, will actually return to you, the system basically can come back to you immediately and say, oh, look, is this better now? And that's the idea underlying what you're doing. You're trying to have the system proposing a different solution and see whether it can actually fix the solution. That's fantastic. And how do you do that? So the next question is, how do we really exploit workarounds? Well, how do we really actually try to solve the problem? And what we try to do is we try to emulate what people do manually. Okay, just go back for a moment and think about what you do when your application does not work. Okay, and this is an example. Actually, it's a true example of a bug from Flickr, which is fixed now, so you don't find it anymore, but it used to be in Flickr. So you have your favorite photos, and your favorite pictures are on your site, and they are private to you. Now, what you really want to do, you really, for example, want to share it with your family, and that used not to work. So that transition from my own pictures to my family picture did not work in that specific release of Flickr. So what you do is basically you look at, can I do something about this before notifying to my favorite developers, hoping he will actually react to me? And this is a Flick developer, not a Google developer, by the way. You go back and say, oh, I can maybe try to use, make it completely public, and then suddenly, immediately go to your family. And it did work in that case. Okay, that's exactly the kind of thing that people would do. You know, if you interact with an application, the application fails, the first thing you do if you are a smart user usually is actually look at the application and say, yeah, I can probably obtain the same effect with a different, in a different way. Okay, and that's what we call workaround, and that's what we call what we look for. We look for what we call intrinsic redundancy. What is intrinsic redundancy? Intrinsic redundancy for us is something which is in the code, which can be used in the code, and thus produce the same or similar effect. So the tricky thing here is, can we automatically look for the redundancy in our code so that we can actually then have the system look at the redundancy in the code and use that redundancy to automatically find workarounds without requiring the user to be smart, or even without requiring the user to be able to access that redundancy, because that's another important problem. You know, here the example is fairly simple. You can play with the interface, you know, and I'm sure, I know, probably many here had some experience of finding to try to get the same effect that they actually didn't get with the most obvious approach by finding some workaround. To do that manually as a user, you really need to sit down and be able to find the workaround through the interface. And in many cases, it's not the case. In many cases, the redundancy is inside the system. So in many cases, what you want to do is you want to actually open the system, look in the system, and use that redundancy. And you cannot do that, while the system can do it. So as a conclusion for this is you really want to have, we learned that your family is equal to anyone in your family. So moving from only you to your family is equivalent to moving from anyone to your family. And that's the kind of information that I'm trying to extract. Like, let me tell you how we do that. We do that in 2 steps. Step number 1. Step number 1 is we look for what we call equivalent sequences. You have an example there. Equivalent sequences are basically something that you can identify and they tell you how. Let's assume that they are there for the moment. So assume for the moment that we can actually look at the system, for example, the code, for example, the specifications, and assume that we can actually extract some information like, oh, whenever you do your family, you go from only you to your family, you can actually go get the same effect by going through anyone and then your family. Or whenever you actually like to do an operation, you can do another operation instead, or you can do the same operation and then another operation and get the same effect. Okay, that's the kind of information we try to extract, and I'll tell you how we do that. At the moment, we actually assume that we have these equivalent sequences, and what we do is something like that. We try to have, whenever the user does find a problem, what it does is simply signals the problem to the system, and the system looks in this repository of equivalent sequences, which is the good one. Tries to find the good one and returns a new page. And hopefully that's correct. And if not, you can repeat it again and again and again. Of course, you know, up to the time where the user says, okay, give up. I don't want to listen to you anymore. So there is always a trade-off between how much the operation is important for the user and how much time the user want to spend on the operation. So if you want to look at a page, it doesn't pop up, you say, okay, forget about that. But if you really want to look at your account, bank account, and decide that you really want to know whether, you know, you want to, what's your balance, and you have time till Monday to get a real answer from the bank, you may actually like to try several times to get the information. So that, you know, depending on the important information, you can go through that loop once, twice, many times. So first part is how do I actually create equivalent sequences? Second part is how do I actually select the equivalent sequence that solves the problem, which is the workaround, what we call the workaround. Let me try to start telling you how do we extract equivalent sequences. Honestly, what we did, we started with a long set of experiments. So one thing that we did, and you'll see it in the second part of the talk, we actually mined the Google bug repository to see whether there were workarounds there, to understand what they were, how they work, why they worked, whether they are automated or not. And we eventually identified 3 major classes of workarounds, or of equivalent sequences. Class number 1 is what we call functionally null operations. These are operations that affect anything but functionality. They may affect timing, they may affect scheduling, they may affect anything else but not the functionality. And I have a simple example there, which is actually probably the favorite workaround in Google application we found, which is set timeout. Set timeout does change the application, because in the set timeout, you have a different timing, different response time. But does not change the functionality. We should not change the functionality better. Okay? Now, we've noticed that in many cases, just inserting a set timeout may solve synchronization problems, may solve race condition problems, may solve many little problems that often arise in many web applications. So what you do is, in many cases, although the set timeout should not change at all the semantics of your application, when the semantics is wrong, when the application fails, inserting the set timeout sometimes helps you solving the problem. And that's one of the possible classes, and we have several others that we'll show you later. Second class of equivalent sequences is what we call invariant operations. There are operations whose functional behavior is important, but they actually complement each other. So, for example, you may, if you have some shown item on your web page, you can hide and show it again. Hiding and showing something which is available doesn't change anything, or should not change anything. There's another kind of thing that may be really, really helpful in terms of solving little problems like an initialization problem, like state problems. So what you may do is basically, yeah, let's actually interplay, hide and show, and see whether they actually work together or not. And that's the second class, which we call invariant operations. Third class is what we call alternative operations. And that's what we've seen before, by the way. And that's what you see many times in many different applications, which is, in many cases, you can really get the same effect through different steps. Okay. For example, in this case, and that's again from Flickr. So these are actually examples from Flickr. So we actually started working on Flickr first. You can set tags of your favorite pictures, and you can add tags, and you can set them multiple set of tags. I hope most of you are familiar with Flickr, not just an application. And you set a tag, or you can set several tags to your picture, and then you have multiple parameters. But you can also set the first tag and then add the other tags. The effect is exactly the same. You actually eventually have two tags, 1 and 2, attached to your picture. But the difference is that you actually use different codes. So if one of the code is faulty and actually brings you to failure, you may try with the other one, and hopefully it doesn't give you the same failure. Okay. Now, how do we work with that? Let me give you some more examples and try to explain you better what they are, and give some concrete examples. And I take something some of you are familiar with, which is Google Maps. Okay. These are, by the way, you see up there issue number 519. These were issues that are issues that you find in the bug repository of Google Maps, and actually was an important source of information for us. And that's one, for example. That's up there. You see a piece of code that is supposed to center the map and display an info window. And it doesn't work here. I don't know whether you see it, but the info window, the picture is very small, but the info window is over the border, so you don't see the info window on the top part of the picture. And the workaround that you find in the actual bug repository that tells you do that to actually solve it is set timeout before set center. And this solves what I think is a synchronization problem between the two things. And adding that simple set timeout would actually give you the correct result. Okay, and that's a kind of one example of what we call functional null operations. Another example, that's another one, issue 1305. There is a function and in Google Maps again that allows you to draw a polyline. And that was faulty in some old versions. These are all solved problems, so it's a history more than just the reality. So don't try now because they work now. That's a polyline, and in that version, you could actually draw the vertices, and you can see the beginning of the polyline and then the vertices, and you don't see the polyline. And what is suggested in the bug repository is again, try to do something which should not do anything, but actually help solving the problem. And that something is basically delete and insert the last vertex. Okay, somehow, and to me it sounds magic because I'm not a Google Map developer, so I look at that and say, wow. But to some of you may actually sound normal or reasonable, by simply inserting something that is exactly what we call an invariant operation. An invariant operation, which means you undo and do again, and you get exactly the same result. Doing that before drawing the polyline would actually make the polyline working. Okay. Third problem, or third class of workarounds is this one. Now, again, the size of the picture does not help, but you may see up there a little red spot in the top picture. That's a marker. And you don't see, I'm sure, this button down there that says delete marker, that you can actually delete the marker. So you can remove the marker, basically. You know, you have a marker that doesn't work anymore, so you remove the marker, that the code, that the issue, and press the button, the marker stays there. And again, you look in the repository and you find out that you can actually substitute the show and the hide operation with different sets of operations. So you substitute the show with an add overlay show, and you substitute the hide with a remove overlay. And they do actually work. And the effect is the same. It's exactly the same. So when you press the button the second time, the marker correctly disappears from the picture. And by the way, you remember I started with an example which is basically playing with the interfaces. This is hidden to the user. You know, your favorite developer can actually help you in removing that the problem by inserting or suggesting that workaround to the application developer. But as a user, you click the button, the marker stays there. Oh, well, change application. If it may not be that important, but may be important, then you can't do anything than waiting for the application to work. So let me actually now go to the second step for a moment. So right now, what I try to show you is that there exists intrinsic redundancy, some intrinsic redundancy. It's of some given classes and can be easily exploited, actually. Is exploited manually in applications to solve problems. Now, let's go for a step further and see how do we actually extract or select the actual workaround. So think about that. You know, I can spend a lot of time, and I'll show you how, to collect equivalent sequences. Now I have, let's say, 10,000 equivalent sequences in my repository. My user says, "Oh, fail," and then I have to pick up one. I mean, I don't know how many users would actually try 10,000 times fail to pick up the good one. Okay, so you really want to have something, and we are experimenting with this kind of thing which we call a priority schema. Priority schema, which is very simple at the moment. We measure two things. One is the success rate, and the other one is the number of successes. So the success rate is obviously the ratio between how many times you succeed compared to how many times you actually use that specific workaround, that specific equivalent sequence. So you pick up set time out 10 times, and it was effective only 5 times. So that's 50% of the times. And the success is actually how many times it actually succeeded. So let's say I have 2 operations. I actually have the example here. I have 2 operations. I have a set time out before a set center. And that's a classic workaround, I would say, in Google Maps. We use it 14 times. And out of 14 times, we got 7 successes. Another workaround is you actually add the show after the add operation. And that's another kind of workaround. We use it only 2 times. And we succeeded once. So we have the same number of success rate, half. But we have a different number of successes. So our strategy so far, and that's something we're working on, is you actually look at the success rate first, and you see how well it did help. So you prefer to get someone with a success rate 100% of the times rather than 10% of the time, 50% rather than 40%. And in the same class, you actually prefer something that has been successful many times because it's likely to be successful more often. And of course, you know, these priorities will change dynamically. Okay, and so in this case, we actually pick up the first of the 2 rules if they both can apply to your faulty page. Okay, and that's actually done automatically by the system. So we have somehow a way of building this equivalent sequence repository with all the possible alternatives that can actually represent a workaround, and a very simple dynamic mechanism that assigns priorities and tells you the more you succeed, basically, the more likely you will succeed in the future. And one more thing is, of course, pages may be used by more than one user. Actually, that's why we look for workarounds. So let's assume that we have a workaround. Let's assume that our poor user has had to go 7 or 8 times through different fail before actually getting a success. So what we do then is basically we store the valid workaround once the user says, yes, that's one that succeeded, so that the next time the next user will try and will see the same failure would actually at the same time have a privileged workaround. We could actually attach the workaround to the user of the page. We don't do that yet because we prefer the user to select workarounds because we're not really sure about how safe is the mechanism. So we prefer to give you the plain application, and if you fail, then you say, well, once you failed, you prefer to actually try a workaround rather than do nothing. That's another part that we actually work on right now. Okay, now let me go through the experimental part, which is sort of prelude for the demonstration. We did run experiments, of course, because that's nice. That's exciting, I would say. It's a new idea, but does it work? So we built a very simple prototype, which is basically a proxy. Okay, you see proxy, and the proxy filters the communication between the user that you have on the left and the server that you have on the right. And in the normal case, the user asks something, and the proxy transmits the request, and the proxy doesn't do anything but inserting that little marker in the page that allows the user to signal a fault. So the proxy needs only to know which is the page and which is the failure, or which page the failure belongs to. So nothing but recording the flow of pages. However, when the user gets a failure, he can signal the failure, and then you actually activate what we call the automatic workaround module that search in the equivalent sequences that are available, discard the ones that are not applicable to that specific page, find the ones that are applicable, try to understand which one is the most likely successful one, apply that, and return the new page to the user, who may be happy and accept. And that's an important information because we store that information and say, look, that's a valid workaround for that specific page. Or may not be happy and try again, or simply give up. Okay? And how do we generate equivalent sequences? Well, we generate them in a couple of different ways. Here I show you one way, which is the one we are using now. And then there is another way, which is the one we are working now. The one we are using now is simply, and we show the experiment, we rely on the ability of the developers. So the first time the user signals a workaround, we ship it to Google, and we hope actually, sorry, the first time the user signals a failure, we ship it to Google. We hope Google actually corrects it and starts populating the equivalent scenario repository. And in a short time, we have something to try before shipping the failure notice to the Google designer. And hopefully, in a short time, we get to a repository which is good enough for us to solve some workarounds. The other situation is to take advantage of the knowledge that you're building up right now, which is your understanding that there are few classes of very frequent workarounds that work very well, can be generalized, can be extracted from the information from the code. And so we look at the specification, we look at the code, and I'm sure you can tell me what are the workarounds, because as Nicholas Beard this morning said, I'm a professor, so I don't program anymore. You do, actually. So I noticed that, for example, set timeout is specified as having no functional operation. So you can say, okay, that's actually category number 1. You may get a bit more, actually, we'll show you later. You can get some other operation that belong to category number 1. So operation that by construction, by definition, by specification, should not affect the behavior, the functional behavior of the system, and so can be inserted. You can look at the specification and say, oh, I know that adding and removing doesn't make any difference. So that's the second class of workarounds or equivalent sequences. And even you may even get information about, oh, adding multiple tags or one tag at a time eventually gets the same results. And then the third category. So in the future, we may actually, we are trying to investigate now whether we can populate that repository with a set of workarounds of equivalent sequences from the beginning. Okay, right now, we don't have data about that. We do have data about the first experiment. So that's actually the report of the first experiment. Let me actually illustrate that. It's a fairly simple report. So I'll tell you what we did. We took, our favorite bug repository, favorite because it actually contains a lot of very well structured and useful information, not because it's particularly faulty, which is the Google Map one. we looked at the issues that were solved as a workaround. So if you look at the repository, you will find issue number 33, 49, 61, 271, blah, blah, blah. These are all issues that we identified as solved with a workaround. And we simulated this game. The first time we start with an empty equivalent sequence repository, and the first time we have failure, the failure is shipped to Google, and Google corrects it. And we actually take the correction, which is in that case a set timeout before an open info window, which is the null, functional null operation, and we put it in our equivalent sequence repository. Stop. Then the second time the user signals a failure, that's actually the entry 49 in the repository. We see whether the equivalent sequence we have, it's only one right now, which is set timeout before open windows applies. And if it applies, we actually try to apply it to solve the problem. It doesn't. So we ship it back, or we simulate the shipping to the Google designer, and the Google designer comes back with another kind of workaround, which is actually an alternative of sequence of operations. And we go ahead, the third time, back, entry number 61, again, we try to understand whether what we have solved the problem or not. Again, it doesn't. It's a set timeout again, actually, but it's not the same set timeout. So look, and that's where we work now. Set timeout works in many cases, but you don't want to simply insert the set timeout at any possible line of code, because then you actually get millions of different things. These are actually privileged locations, because they're all locations before instruction that are potentially interfering with other instructions because of some race condition or some ordering condition. So you put the set timeout before an open info window, before a set center window, not in general. And in our experiment, we were sort of very frustrating, because we started the first, the second, the third, the fourth, the fifth, and none of them was actually reusable. Oh, the sixth was, the seventh was, and wonder why? After the fifth, most of the times you actually succeeded. So what you see in that picture is two things, actually. The first thing you see is down this red and green line, okay? That red and green line is a summary of the 24 problems we actually analyzed in that order in the Google bug repository, and we try to use exactly this approach. Start with an empty equivalent set, try to populate with the first equivalent sequence, try to use that for the second one, fail, populate again, third one, fail, populate again, and you notice that after 1, 2, 3, 4, 5, then the success rate is really, really high. Okay, so we really have that if we had this system in place, we could have had most users happily served by the system itself without having you guys involved in the repairing. Okay, and that's because from a given point on, the set timeout with the set center is fantastic. It solves a lot of things. The set timeout before the open info window, it solves a lot of things. And so on. And you see also, we record that the experiment is not that big, actually. It's only 24 problems so far. But you see, we have the workarounds we've been using in the 24 cases. So a reasonably small amount, okay? That gives you also the other feeling that it's not that you have one problem, one workaround, another problem, another workaround, another problem, another workaround. No, you have one problem, one workaround, oh, another problem, the same workarounds work again, or the same workarounds work again. So that's why we are really thinking that in the near future, we can actually give some partially automated rules that can say, okay, look, pick up all the operations that share some common features with open info windows, with set center. The feature is obviously the possibility of interfering because of different timing, and generate automatically potentially useful workaround, which is put the set timeout before. Okay, pick up, and so we really think that this can actually be partially automatically generated. Even if we cannot automatically generate it, we can simply live with the same situation we have now for the first part of the first life of the system, and then soon get to the point that the number bug reports goes from like 100 to 10, at least for this specific kind of bugs. Oh, we have another thing down here, which I try to explain you what it is, because the other question is, how much do we annoy the user? Of course, you know, we're the shoes of a user right now. You try to get something done, and you fail. Okay, being able to say, oh, fail, and then you get another reply which is correct, or press again, fail, and get another reply which is correct. I'm sure you don't mind do it 2 or 3 times, not for every page, of course, you know, but let's say once in a while. You would mind do it 20 times. So we also measured the efficiency of our priority schema, which is fairly simple, and of course it works on a small set of workarounds, but you think then they can be applied in many different pointers of the JavaScript. So in general, you know, a single workaround can be applied many different times. And we found out that we measured the average number of attempts for each workaround before solving the problem. So 1 means the highest priority workaround did work for the first time, okay? And in many cases, it's actually the results. And the worst case we had so far is 2.8. So within at most 3 clicks, we often get, in average, we solve the problem. So that's an average number of applications per workaround. I don't know whether it counts as this or not. It's a good measure, actually. You know, you can actually, we have, I think the worst case was 10 clicks, if I remember, which is annoying, but not that annoying compared to waiting for 3 months for someone you don't know solving the problem and sending and shipping the solution. Okay, so applicability. Okay, so far I tried to convince you that you have a good idea. That's easy. And that it can work. That's a bit more difficult. How often can it work? You know, because you say, oh yeah, great. If you can solve 2 problems per year, oh come on, you don't really help us too much. Yeah, I do, but you know. So we try to extract this simple measure, which is we took again the Google Maps bug repository, and we use this simple search mechanism, which is look for pattern matching, look for workarounds. And we found the word workarounds in 63 different entries. So I don't have enough students to actually have them looking at each single entry or each single fold, but you know, I could have people looking at that 63. So we look at that 63, and only 43 actually are workarounds, because you know the word workarounds appears in things like, oh, this is a problem, it may be solved with a workaround, and that's not a workaround. You know, but there are some cases where it's actually a workaround. So out of the Google Map repository, we've been able to identify 43 actual problems that have been solved with a workaround. And then we took them and we tried to solve them with our automatically generated equivalent sequences. And we found that 14 out of them can be solved. So now, if there is anyone strong in statistics, stop here, because you know, of course, the numbers are small, so you can't generalize too much. But at least in this experiment, we can claim that we actually can find automatically 33, 1/3 of the workarounds that you guys generate manually right now. Not a big number in absolute terms, 14. But if you generalize well enough and you think how many times you actually use that for solving the workarounds, it can be a big amount of saving in terms of the work. Now, at this point, I want to convince you even more by having Alessandra showing you a short demo about what we did as an experiment. So Alessandra will show you both 2 different experiments about the effectiveness of the workaround and the effectiveness of this notification of the success to the actual system.
Yep. Thanks, Mauro. Can you hear me?
Yes.
Okay. So I'm going to talk about a couple of issues in Google Maps. So is there any Google API developer near? Good. Much better like this, so that you don't hate me. Okay. Now let's see what happens when the user is not using the automatic workaround approach. So here we see a Google map, pretty simple, that can be dragged. And as you can see, there is a marker in here. that is centered in Zurich, where we are now. And what we should see is an info window that appears as soon as the user clicks on the marker. But trust me, I'm clicking and nothing happens. So what can the user do now? Nothing. The user can just hope that the person who developed this page somehow realizes how to try to find a workaround and avoid this problem, or wait until the developer goes into the Google Maps issue page and report the issue to the Google Map developers, and wait until the developers fix the problem. And this is actually a known issue. This is the issue number 1118, and as you can see, it's been reported in here, and it's now fixed. But yeah, again, until the developers don't fix the problem, then the user keeps experiencing this. And all the applications who are using that particular function that fails will also have failures, so no other pages. But now let's see what happens when the user instead is using the automatic workarounds approach. So now I'm going to start the proxy. Okay, and now I already configured my browsers to go through this proxy. So now, as soon as I reload my page, the request will go through the proxy. So now let's see, it works. Yes. So as you can see, I again have exactly the same page, but I have now this small button on the top left corner that says find workarounds automatically. So when the user sees that the page has a problem, as we see here, because again the application is not working, because when we click on the marker nothing happens, the user can now say that there is a problem here. And we see that the page, the map is reloaded. So and we see that now the application is working. So whenever I click on the marker, I successfully can see the info window. Now let me try to tell you a bit what we did. And by doing that, I need to show you the original code of the Google Maps API that we saw in the page. And as you can see, it's pretty easy. Yeah, should do this so that you can read it better. So basically, in that map, we just create a map. Then we set the center to the Google Zurich office. Then we add a marker, and then we associate to the marker an info window. Okay, and the issue that we're talking about actually involves exactly this operation here. So basically, the problem is that for an old version of the Google Maps API, this method was just not working. So what indeed was working was to, and this is now I'm showing you the new code that has been loaded after we tried to find the workaround. As you can see, it's exactly the same, but in here, the bind info window HTML has been substituted by an operation that is equivalent. That is, associate to a marker the function that open an info window HTML, and whenever the click event occurs. Okay, so this was easy because we managed to do it the very first time, but we'll see that it doesn't always happen. So now let's go on to the second case study. Again, we have another Google map. In this case, I cannot drag the map, so it's fixed. I have instead a fixed marker and if I click on it, I see again where we are. That is the Google office. And then I also have another marker that can be moved. Okay? By clicking on this marker, I should again see an info window. But again, I don't see it. So this is another issue that is known in Google Maps API. It's the issue number 33. And it's pretty annoying because it's one of the oldest, but it's still open, although there is a workaround. So in this case, the user tries to ask for a workaround, and we see that it doesn't work. We'll see now what is the first workaround that has been tried. And actually, maybe I should first show you the original code. It's this one. As you can see, that in the original page, there's nothing but the creation of the map, then the creation of a marker that can be dragged, and if you notice this, we associate to the marker the info window by using the add listener operation, and then we do the same for the other marker. So if you remember the previous case, we used exactly, and now I'm switching to the new JavaScript code that has been executed now, but that still doesn't work. As you can see, the first workaround that has been tried is to substitute the add listener with the bind info window HTML. Why? Because it worked before, so it can work also in the other way. But in this case, it didn't. So now we go on. I'll try to ask for another workaround, and I mean, we broke the application even more, actually, because now we don't even see the markers. Now again, I don't know if you want to see the code of the new code that has been loaded. Basically, in this case, is to add a set timeout here while disabling the dragging. And let me go back. Yes. So, but still, it doesn't work, as you can see. Now we go again, and finally, I can tell you already that this is finally successful. Okay, and I can see that I can still click on the fixed marker, and still the application is working, and the map is still not draggable. So now I'll show you the valid workaround. That is basically to insert a set timeout when you call the open info window HTML function. And so what is the point in here? Well, in the first case study, we successfully could find the workaround at the very first time. This time, it took us quite a lot of attempts before finding the valid workaround. So as Mauro said, so actually, since we found the workaround, I should actually say to the system that I found it. So now that I found a workaround, what happens if another user is asking for the same page? Well, I'll simulate this by opening another browser and by calling again the same page. As you can see in here, the user still experienced the problem because by clicking on the marker, nothing happens. But as soon as he asks for a workaround, then the workaround that was successful for the other user is the first one that is tried. So that's pretty much conclude the demo. So I'll give the word back to Mauro such that it can conclude.
Wrong thing. Okay, so a couple of words for concluding and letting you ask a question, hopefully. I wanted to sort of start from the beginning and tell you what we really try to explain here. First of all, a completely new way of looking at the problem. We're not trying to solve the testing problem by itself, although we have other project on that. We're trying to actually look at a different perspective, which is not substitute but complement testing. You know, we cannot get rid of testing. We do need the good testing. What we're trying to do is we're trying to get rid of some of the annoyance that comes after testing. You know, when you actually get system, despite good testing, despite good maintenance, still breaking in the real world. And the other thing is this is not a magic tool, so it doesn't solve every problem. You know, in fact, we actually focus only on the problems that can be solved through automatic workarounds, and some of them cannot be solved automatically at all. So in general, the goal is not, or actually the goal could be to solve all problems regardless what they are, but you know, let's say our shorter term goal will be actually to solve some of the problems. And you know, we really believe if we get rid of 10, 15%, 20% of the user reports, we save a lot of money. Anyhow. We save a lot of effort, and we put that effort in many other different things. Another thing we notice is that, and you've seen that there is a sort of a set of information that accumulates and may be useful for the developer itself. So in some cases, and we mentioned like some bugs which are still open, and we actually did. We didn't show that. We don't have time. But we are starting these new experiments, which is get the repository of workarounds we have now, apply it to open problems, and try to see whether it works. And it did work, actually, indeed, in a couple of cases. Of course, you know, it's not that frequent, you know, because, first of all, because it takes a lot of time for each experiment. And again, I don't have that many students to be able to run too many experiments in parallel. But, you know, it is actually interesting to see that sometimes you get an open problem that probably simply did not attract the attention of anyone in Google yet. And it can be solved. Partially, maybe. No, it's not the solution. It's basically like a sort of patch that you put on the problem to let the user work a bit better without actually interrupting their flow of operations. As I mentioned before at the beginning, it's an open project. We're putting a lot of effort in it. We're getting the first good results out of it. We believe it is applicable more extensively than just web application, and we are actually applying it to other classes of applications. We have some problems also with other classes of application because there are two elements that actually I didn't mention explicitly, but are actually very important. In this kind of application, the user can actually report the problem. You know, in another system, reporting the failure is not easy. And the other problem that we have is you can apply the workaround as many times as you want, and the page reloads completely. And reloading the page reloads completely the page. You know, you don't want to be in trouble with a database where you actually try to insert as many information as you want to try to solve the problem. So you have the problem of stability of the state. So it's not that generalizable. We see a big improvement in being able to generate equivalent sequences or scenarios automatically. And I think we can do that. One thing is actually important, we really need more data and more experiments. Now, let me spend one word on that, and to conclude really, I want to say Google Maps is not just suited for this audience. It's also important for us because of specific advantages that we find only in Google Maps, which is we do have a very well-documented set of bugs, and we can actually reproduce the bugs. That's actually very important for us. And we are thankful to Google for this, because I think that's maybe without even knowing it, but was a big help to our work. And my last message is if you have problems, if you have bad repositories, you may not want to disclose everything to us, but just ship the problems, try, and we may tell you whether the system works, and that will be a very big help for us. Thank you.
Hi. So from my experience, developers don't like testing. Developers don't like debugging. A developer likes progress and then likes to release and have more progress. Do you worry at all that while all this kind of automated workarounds is useful and good for the user, it discourages the developer from actually fixing the root cause of the bugs by making it less of an issue for them?
Oh, that's actually a very interesting question because we did have a much larger project at some point which was about self-healing. So this is part of it actually, which is not just try to find a workaround, but just to fix the whole system. And we're working on a European project with a company developing software for avionics and aerospace. And they said, we don't want that stuff because we don't really want our engineers thinking that they can develop buggy software just because we can automatically fix it. But that's a human factor more of that. You know, I think, yes, you're right. I think, let me say one more word. I think that's the way I teach, actually. Software engineering is, first of all, a human intellectually intensive activity, brain-intensive activity. And anytime you must believe, you must think that the human is in the loop. You know, you cannot get the human out of the loop. Of course, if you look at this as, oh yeah, I can ship buggy software because anyhow somebody else will take care of that, that's going to be a disaster. But if you actually put this in place, in parallel with what we have now and what is actually improving now, that's going to be much, much better. Thanks.
And if I can add something, from our experience with all the bugs that we studied on Google Maps, basically all except one that already has a workaround known, all the bugs have been fixed anyway. So I think also the ability to identify a workaround automatically can also help the developer to find a better fix, because for a workaround that we don't know why it works can be a useful information for the developer, because the developer for sure has more knowledge about the code. So.
How does the system know what is the problem? In the demo, we don't see how the user report a problem. And the second question is how, if you have some equivalent sequences for a particular problem in your repository, how do you identify, how do you link it with a new problem? What's the criterion to decide that these two problems are actually similar or the same?
Okay, the first one is fairly simple. The user has this little button on the top that says, try to find a workaround. Actually, probably, you know, in the demo, you've seen this information on the top. It was used for the demo. You know, I would expect saying, wrong page, try again, or something like that, you know, because I understand that, you know, the classic user would not say, find an automatic workaround. It would say, wrong page, give me another one, you know. And that's a very good point, actually. As I mentioned that at the very end. It's a very good point because actually that's one of the major problems in applying these techniques outside the web application environment, because we really need someone who tells us this failed. So in this case, the user clicks and say page failure, and that's when we trigger the application. We try to use it like for Java programs, and the Java program doesn't tell you I failed, and then it's going to be more difficult.
For the same page, the problem can be that the map is the wrong map, or the scale is different.
Oh yes. No, okay. So the only information we have is, not going back to the first question, is at some point the user sees something that does not satisfy him and clicks new page, please, or try to fix it, please. Wrong page, please fix it. That's actually it. The second question is, if you look at the different workarounds that we had, okay, there is a concept. We do have a formalization of the workarounds that actually tells you how to apply them. You can see them, for example, the first one says, if you have an open info window, you may actually set a timeout. Now, Now, if you don't have any open info window, it doesn't apply. It applies only to pages with an open info window. Another one says you can actually, instead of add overlay, you can switch between add overlay and show, or remove overlay and hide. Okay. Again, if you don't have any of these occurrences in the code, it doesn't really help you. So it's basically by context. And going back to the question, that's actually I say it's not magic. It doesn't solve the problem all the times. It may solve the wrong problem. In fact, you've seen, in the second example, it tries 7 times before actually getting to the problem. The question is not, so let's say you should not see this as an alternative to a fault-tolerant system on your favorite aircraft. Don't take that aircraft, actually. It's more like, it's more like, I really wish I knew what's in that position and I can't get to the info window. Okay. Can you try once more? Can you try once more? And we in fact, in many cases, we will fail completely. And, the user tries 2-3 times to say, look, I don't care anymore what's on this info window. So you can think of that not just like the absolute solution. So, for example, if the problem is that you want to drag the page and it doesn't drag, okay, of course, then, there may be actually a workaround that applies to that. So, in fact, what Alessandra showed you are two things, was failure, click to signal the fault, try to see whether it solved the problem. You've seen, for example, that in some cases the two markers disappear. You say, gee, no, that's not what I want. It may actually have been what you wanted, but it was not. So the system does not know what's right, does not even know what is wrong. It simply knows that there are some elements that can be actually fixed. And fixing may be wrong. So, but the point is, in 1/3 of the cases, it has been correct. And that's actually what encourages us. Okay?
Thanks. And this also sort of answering the second question. Yeah.
Thanks.
Because the user has to click something, yeah. Have you thought about trying this with real users and seeing how many times they would actually click, fix this automatically? Is it your average user, if something takes more than a second to load, is going to go, right, I want to move to another website because I'm bored of this. They're going to probably click fix this automatically once, if they're going to click it at all, and then move on. Have you thought how you're going to tackle that option?
Well, you mentioned two kinds of users, real users and average users. Our users are students, so they are real but not average. So no, to be honest, no. The prototype is in the early stages, so we do actually work on prototypes. We do actually work with students. We cannot afford to work with real users yet. That is average users. So, and of course, if I tell students, can you try and see how many times it works? So they would try and try and try and try and try and try. They would not stop. So this, again, these human factors or this psychological factor that say, how many times you try before giving up? I can report you, and you probably know them very well. Many users do not go through beyond the second page, the second click, or do not. Although the good encouraging thing is this one, which is many cases the first time you click you get the right page. So assume you open your, let's say, the University of Lugano web page, and you open the Google map, and there is a nice marker, and you want to get information and doesn't get anything, and you really want to come to University of Lugano, so you click again and you get the information. And I think once it's worthwhile, but no, we didn't actually make some mistakes.